These next set of problems, if you notice already, they look a little bit different from the ones we've been doing. But again, they are still absolute value equations because they have an absolute value bar in them, an expression, I should say. The first step, the first few problems we didn't have to worry about this step, was to isolate. Again, when we're talking about isolating an absolute value expression, what we are trying to do is to get the absolute value bars and whatever's inside the bars by itself, meaning that should be the only thing on that side of the equal sign. So again, I like to do is see what's my absolute value expression by making sure that I make my wavy brackets to show me this is what should only be on the left side. Now that I've done that, you should notice that what is not included in that wavy bracket, it is this plus 5. So I need to get rid of this plus 5 in order, because again, I can't move on to step 2 until I am done with step 1. In order to do so, I'm going to subtract 5 from both sides. These 5s cancel out, meaning that on the left side, I should only have the absolute value of x minus 2 left. And it's equal to 4. Again, it's going to be your job to determine, is my absolute value expression isolated? Is the only thing on the left side of the equal sign my absolute value bars and whatever is inside? In this case, it is. So the next step we're going to do is to create our two equations. You take, again, whatever is on the inside. In this case, it's x minus 2. Set it equal to the positive and the negative of the number it is equal to. Now that I've done that, we're going to do step 3, which is solve. I'm going to add 2 to both sides. X equals 6. That's for the first one. Add 2 to both sides here. And x equals, again, just because this is 6 doesn't mean this is negative 6. Negative 4 plus 2 is a negative 2. Now that we've solved for x, the last step is to check your work. In order to check your work, again, you're using the original equation. That means this one all the way up here. We're using the original equation, and anywhere I have x, I'm replacing it with the value that we got as an answer. I'm doing one at a time though, so I'm first doing 6, and then I'm going to go and do negative 2. So I have 6 minus 2. It's the absolute value of 6 minus 2. 6 minus 2 is the absolute value of 4. And then bring everything else that we didn't use. Plus 5 equals 9. What's the absolute value of 4? That is 4. And then plus 5 should equal 9. 4 plus 5 is 9, and it's equal to 9. Does 9 equal 9? That's a true statement. Yes, it is. So that is telling me that x equals 6 is an answer. Now I'm going to check my other problem, my other solution. Again, I replace x with negative 2 because that's what it's equal to. Negative 2 minus 2 is the absolute value of negative 4. And again, I wrote everything else that I didn't need to, that didn't have an effect on the problem. The absolute value of negative 4 is just a plain old-fashioned 4. Plus 5 is equal to 9. 4 plus 5, we know, is 9. So 9 does equal 9. That tells me x equals negative 2 is also an answer. Here's our next problem. Now, some people read these differently. Some people read it as -4, and then the absolute value of 8 minus 5n equals 12. Notice that between the -4 and the absolute value bar, there is no operation. What that is telling me is that this is not just -4 then the absolute value. This is -4 times the absolute value of 8 minus 5n is equal to 12. What that tells me again is that I'm going to have to isolate. Again, our first step is to isolate the absolute value expression. That means I want to get that by itself. In order to get the absolute value expression by itself, I have to get rid of the -4. And since I'm multiplying by -4, what I'm going to do is divide by -4. And what I do to one side, I do to the other. The -4s are going to reduce down to 1, and I'm simply left with the absolute value of 8 minus 5n is equal to -3. Now that my absolute value expression is isolated, I can go and do step 2, which is to create my two equations. Again, we're going to take whatever's on the inside, set it equal to the positive and the negative. Since we're starting at -3, that one's going to be -3, and this other one's going to be that +3. And from here, we solve for n. This is 8 minus 5n. Again, your goal is to get n by itself. This is one of those weird looking two-step equations where a lot of people want to add 5n, but that's not helping me get n by itself. The first thing I'm going to do is get rid of this 8 by subtracting it. -5n is equal to -11. Divide both sides by -5. N is equal to. Now, it's always going to be easier just to leave it as a fraction, but -11 over -5 can reduce. They are both a negative over a negative, so it's a negative divided by a negative, which will give me a positive. So n equals 11 over 5. Let's do the same over here. -8 on both sides. -5n is equal to -5. I'm going to divide both sides by that -5. These reduce down to a +1, and n is equal to, well, you look at that, a +1. Oh, I didn't even write down step 3, but that was step 3 we had to solve. I'm going to write my answers to the side because I don't have enough room on this whiteboard, so I'm going to have to erase some stuff. So we got n is equal to 11 over 5 and 1. The last step is to check your work. So again, we're going to use the original equation. I'm going to start with the first answer, which is 11 over 5. And that should equal 12. To simplify it, I first got to multiply -5 times 11 over 5. The 5's cancel out. So I'm left with -4 times the absolute value of 8 minus 11, which is equal to 12. 8 minus 11, again, that's still in the absolute value bars, is -3, and that should equal 12. Again, this is -4 times whatever the absolute value is. In this case, it's -4 times, and the absolute value of -3 is a +3, and it should equal 12. But a -4 times 3 is a -12. And a -12 does not equal a +12, which means, again, 11 over 5 is an extraneous solution. Again, just because one is an extraneous solution does not mean they both are going to be extraneous. So we still need to make sure and go through and check our second answer. I'm replacing n with 1 now. The negative 5 times 1 is a negative 5 still. 8 minus 5 is 3. Again, it's negative 4 times the absolute value of 3. And the absolute value of 3 is 3. And again, it's supposed to equal 12, but negative 4 times 3 is a negative 12. So negative 12, does that equal 12? No. That means 1 is also not a solution. It's an extraneous solution, which means the answer for this problem is no solution. We're going to do one more. We have 4 times the absolute value of x plus 8 minus 1 is equal to 11. Know that sometimes a problem like this, people might write it like this. It looks super weird this way, but know that people are going to write a problem like this, and if you don't like it this way, you can always rewrite it. If it's adding or subtracting, you can always move it around. That's the one good thing about that. But again, these problems will be done the same exact way. First step is to isolate. Again, I want to isolate the absolute value expression. That means I want to get the absolute value bars of x plus 8 by itself. That means I got to get rid of this 4 and this minus 1. This is 4 times the absolute value, and then this is just the minus 1. Just like we did our two-step equations, our first step is going to be to either add or subtract. So I'm going to add 1 to both sides. So then I'm left with 4 times the absolute value of x plus 8 is equal to 12. Now that I added 1, I'm still not isolated all the way because I got to get rid of this 4. So here I'm going to divide by 4. These 4's reduced down to 1. I'm left with the absolute value of x plus 8 is equal to 3. We have officially isolated the problem. From here, I can create my two equations, take whatever's on the inside, set it equal to the positive and equal to the negative of the number it's equal to. So I have it equal to 3 and negative 3. What I'm going to do next is solve for x by subtracting 8 from both sides. X is equal to negative 5. And x is equal to negative 11. I wrote it over here so I can keep track because I'm going to have to erase it because I still got to go back and check my work. Again, to check your work, you have to use the original problem. So we're checking negative 5 first. So we have 4 times the absolute value of negative 5 plus 8 minus 1 equals 11. We got to simplify the absolute value bars first. Negative 5 plus 8 is a positive 3. Bringing down everything else I didn't use. Again, that's still the absolute value of 3. And just like earlier, it's 4 times the absolute value of 3, so it's 4 times 3, because the absolute value of 3 is a positive 3, minus 1, and it's equal to 11. Here we follow order of operations. The first thing I need to do is take 4 times 3, which is 12, and then subtract 1. 12 minus 1 is 11, and it's supposed to equal 11. Since 11 does equal 11, that means that negative x equals negative 5 is a solution. Now we're going to try the next one. The next one's negative 1. Well, not negative 1, negative 11, my bad. Negative 11 plus 8 is a negative 3. The absolute value of negative 3 is, well, a positive 3. Remember, it's being multiplied with 4 and then subtracted by 1. 4 times 3 is 12. Minus 1 should be 11. 12 minus 1, well, that is 11. Does 11 equal 11? Yes. So that means x does equal negative 5 and x does equal negative 11. I know that we said it was going to be the last problem, but I still want to just briefly talk about a problem like this. So here we have 4 minus the absolute value of x plus 2 equals 7. All I'm going to do with this problem is isolate it. We're not going to go through this, so we're just going to isolate it. So our first step, again, is to get the absolute value by itself. You have 4 minus the absolute value. Now, you want to remember that if there's a minus sign and then there's not a number in front of something like this, it's that invisible 1. Which then should tell you that what's that negative 1 doing? It is being multiplied. So again, think of it as a two-step equation. The first step was to add or subtract. Then it's to multiply or divide. We have to get rid of this 4 and this negative 1. Since the negative 1 I just said was being multiplied, that means we got to do step 1 first, which is to add or subtract. That means we got to get rid of this 4 first. Since it's a positive 4, I can simply just subtract it from both sides. And I'm left with the negative absolute value of x plus 2 is equal to 3. Here, then, I will divide both sides. Again, some people just put the negative, but if you need to, remember that it's a negative 1. The negative is reduced down to a positive, so I have the absolute value of x plus 2 is equal to negative 3. And now that I've officially isolated the problem, I can go and solve the equation, which I recommend you guys doing. Please make sure, again, you watch the videos, you take your notes, and then do the problems.